Okay, students, this is my introduction to equivalent fractions, and we're just going to practice making equivalent fractions by decomposing them into smaller parts. That means taking these bigger parts and breaking them into smaller pieces and finding out that they are still equivalent. And of course, the word equivalent right here means equal to, right? So let's take the fraction 2/3, and you can see that we have shaded in 2/3 of this particular fraction bar. So there it is. It goes from there to there, and that is 2/3 of it. But what if we broke each of those thirds into equal parts, right? So now we haven't shaded anymore, and we haven't taken any of the shading away. We've shaded the exact same amount, so we have still shaded 2/3, but now we have a different fraction. So we have 1, 2, 3, 4 parts that are shaded out of 5, 6 total parts. So now instead of 2/3, we have 4, 6. And that is a fraction that is equivalent to 2/3, right? And you can see that we can not only model it right here on a tape diagram or a fraction bar, but then we can also show you mathematically how this works, right? So we can say that 2/3, right, is equivalent to 1/6 plus 1/6. And we're making it a sum of unit fractions here. And you can see that all the different little all the different little sixes that go together to make 2/3, right? 1, 2, 3, 4, 6. So 4 groups of 1/6. You could also do it like this. You could say that 2/3 equals 4 times 1/6, right? And either way, no matter how you do it, you get 4/6. So we know now that 4/6 is equivalent to 2/3. All right, let's look at this another way, shall we? Okay, take a look here. We can make a different type of an equivalent fraction. So now here, we have 2/3, right? So there's your fraction 2/3 going from there to there. But what if we broke each of those thirds into 3 equal parts, right? So instead of 2/3 now, we have a different fraction that is equivalent to 2/3. So now we have 1, 2, 3, 4, 5, 6 parts shaded in out of 7, 8, 9. So 6 out of 9. So we now have 6/9. We now have 6/9, ladies and gentlemen. And there we go. So 6/9 is equivalent to 2/3, right? And so over here, we can say it like this, 2/3. Now we could add up 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 and get 6/9 that way. Or we could do it the faster way and we could say that it is 6 groups of 1/9, right? And that will give us 6/9. So there you go, ladies and gentlemen. That's how you can decompose a fraction in a tape diagram or in a fraction bar and create equivalent fractions. But let's go ahead and do it in a different type of a model. So you can see here again, we have 2/3 shaded in. So once again, we have the fraction 2/3. But this time, let's break it down this way. And we'll draw a line straight across the middle like that. So now we still have 2/3 shaded in, right? So here's the 2/3 that we originally shaded in. But now when you look at it, you now have 1, 2, 3, 4, 5, 6 equal parts, and 4 of them are shaded in, right? So now the other way to look at this is 4/6, and that is an equivalent fraction, right? So 2/3 once again equals 4 groups of 1/6, which is equivalent to 4/6. So you can see that this is just a different type of a model that looks at the same exact set of equivalent fractions. Let's do it again down here. Take a look here. We have 2/3 right there. Okay, and in this model, we're now going to break each third into 3 equal parts, or break each third into thirds, right? So now instead of 2/3, we now have 6 of them shaded in out of 9 total parts. We now have 6/9. 9 instead of 2/3, right? So the 2/3 is here. We didn't shade more, we didn't shade any less, but we got 6/9. We simply broke the 2/3 into smaller pieces, right? And a ninth is smaller than a third, so it takes 6 of them to equal 2/3. And we can write that out over here. So 2/3 is just like this. Now we could add, right, 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9, or we simply say 6 groups of 1/9, and that, of course, equals 6/9. All right, so we figured out how to do equivalent fractions now with models, both a tape diagram and just a rectangular model. But what about with just multiplication? So if you have a fraction like 2/3 and you want to do an equivalent fraction, well, one way to do it is to multiply it by both the same numerator and the denominator. Now, take a look. The numerator, if you multiply it by a fraction that has the same numerator and denominator, well, you'll find out that 2/2 actually just equals 1, equals 1 whole. So I'm really saying 2/3 times 1. But by multiplying it by the same numerator and denominator, in this case 2, in both situations, I can multiply straight across. 2 times 2 is 4, and 3 times 2 is 6, and I get 4/6, which is the same equivalent fraction that I had over here when I did it on my model, and the same one that I did on the very first page. All right, so that's how you can do it with just multiplication. You can also do it. I'm going to do 2/3 this time, and I'm going to say multiply it times 3/3. Now, you'll know that 3/3 also equals 1. Anytime your numerator and denominator match, it equals 1. So I'm saying 2/3 times 1. But by doing it by 3/3, I can say 2 times 3 equals 6, and 3 times 3 equals 9, and there's another way to get an equivalent fraction. So 2/3 is equivalent to 4/6, which is equivalent to 6/9. All of those fractions represent the same amount. So that is an introduction to equivalent fractions. I do hope you keep practicing, you keep learning math, and pay attention in class. Bye.